Next, we're going to look at an exponential trend. You can fit this in a linear regression by using log of your dependent variable. The constant that you're getting is the log of the constant. Just remember that if you want to use those estimates, you always need to convert it back. Okay, let's generate a log series. Again, you don't have to do this, but just have a variable, and if you want to plot it together, it's just easier. So let's call this ln rtrr is equal to log of rtrr for the entire sample. Okay, so now you have your log. Now if you graph it, you can see that it looks like it has a linear trend. So it's the same US retail sales, just a log of US retail sales. So let's fit a linear trend on this log. So quick estimate equation. So ln rtrr, and there in the drop down menu, constant c, and then just time or at trend, whichever you prefer. Okay, right, so there is your log linear regression. The dependent variable here is log of US retail sales, not US retail sales. So some of these statistics that you see at the bottom, these are not comparable. So we're not going to fill this Excel file with these statistics. Instead, we will need the exponential trend. But if you want to see how it fits, you can see it fits pretty well. There seems to be a slight curvature still in the residuals. Okay, if you want to forecast the entire series over here, because we're not comparing, that's why I'm not changing the in sample out sample, but you can see what it looks like. You can also, let's put the actuals here. Okay, there you go. So you can see the log series, the log US retail sales, and then the solid blue line, that's the forecast. Okay, stops from the actual data stops at 1995, but then the forecast goes on. None of these measures are comparable with the linear or quadratic. We'll need to convert it to an exponential. Let's save. See, another way you can fit log linear trend. So estimate, and then instead of ln, let's erase the whole thing. Let's try log of rtrr. This will give you the log, c, and then at trend. So you don't have to create the time series, you don't have to create a log series, you can directly enter it. You should get the exact same thing. Right, so let's go back to estimate, and then let's see with the other equation, you should be able to get the exact same thing. So replacing the log with ln rtrr, and then a trend with time. You see the results are exactly the same, nothing has changed. Let's name this equation. So it saves it. So log linear equation. For it to be comparable, we have to use an exponential. So let's model that. So RTRR is equal to C1 times exponential. So if you go back, you see it's beta naught, E beta 1 times time naught. So that's C1 is your beta 1 times, sorry, C1 is your beta 0. Exponential times, or exponential parenthesis C2, so that's your beta 1 times time. Okay, close parentheses. Let's change the sample till 1992 December. Okay, unmatched parentheses. Let's go back and see where the error is. Okay, there is an parenthesis before exponential. So can add another parenthesis here. Actually, let me just remove these two. Yeah. Okay. There you go. So RTR, you have this in an exponential linear regression, a linear trend, exponential linear trend. Okay, let's name this as exponential. exp underscore equal. This just overrode the log, so I don't know if you want to do that or create a separate one. Okay, so these statistics are now comparable. So these adjusted R square, AIC, SIC, these are now comparable. Let's go to the residual plot. There you go. You can see how it fits the data. So some parts it fits well, some parts it does not. Okay. You don't always have, the data does not always have to fit perfectly because that gives you a risk of overfitting. Let's go ahead and forecast in sample. So till 1992, December, uncheck insert actuals for out of sample, forecast, and actuals. There you go. You can see that after around the 1990s, it's sort of the forecast steps away. So we can now write down what is, this is the in sample. You have 4699, that's the in sample. Okay, let's go back and forecast the out of sample. So forecast the out of sample from 1993 month 1 to 1995 month 1. Okay, so this will give us the, you can see this is the for the model evaluation. Uncheck the box for insert actuals and forecasts. Okay, there we go. So you can see the actuals. This is much lower than the forecasted. This was incorrectly placed here, so let's move this to in sample. Okay, and then our out of sample forecast error is out of sample root mean squared error is 1637317.51. Okay. You can see it's much higher than the in sample forecast error. Okay, let's go back and then get the remaining statistics. AIC, SIC, and adjusted R squared. Okay, adjusted R squared, Control C for the exponential trend, Control V. Okay, let's get our AIC and SIC. So AIC, Control C, no. In the edit mode, that would be nice. Okay, but Control V, and then back to our SIC, Control C, Control V. Okay. Now we have all the statistics that we need for comparison. You can see the adjusted R squared seems to be better for the quadratic model. So let's highlight that. And then the AIC and SIC are both lower for the quadratic model. So highlighting those. And then both in sample and out of sample squared error seems to be much lower for the quadratic function. Okay, so this out of the three, it seems the quadratic trend is the better model for forecasting. Okay, let's save our exponential forecast. This will go for the entire sample, keep the box checked, and then forecast and actuals. Okay, there you go. There is your forecast for US retail sales using an exponential trend. So freeze and save this graph. All right, let's save it as exponential trend forecast. So exponential trend forecast. Okay. Oh, let's add retail sales. Okay. Go back. Now you have all three graphs for linear, quadratic, and exponential. So exponential forecast, linear forecast graph, and then quadratic forecast. Control, open them all together. You should be able to see it. I don't think this is the best visualization. Maybe you can see the axes are different. It might be better to just plot the three forecast lines with the actual. Delete graph. Let's go ahead and select US retail sales, exponential, linear, and quadratic forecasts. Then open them as a group, view, graph. Okay, in a single graph. Now you can see all the series are together. So you have US retail sales. I believe the retail was not saved till 1996. That was an error on my part. Okay, but you can see the red line is the quadratic, the orange is the exponential, and seems the exponential goes off a little bit where the quadratic fits the data a little bit better. There you go. Let's freeze and save this graph so you can later use it. Okay. Let's name this to save it. Maybe not graph, but forecast underscore graph. Okay, there you go.